Hey everyone, today we'll do the Canadian Computer Computation Test, year 2018, Junior Problems, Problem J5. Choose your own path. Now let's read the problem. So there is a genre of fiction called Choose Your Own Adventure books. These books allow the reader to make choices for the characters, which alters the outcome of the story. For example, if after reading the first page of a book, the reader may be asked a choice, such as do you pick up the rock? If the reader answers yes, they are directed to continue reading on page 47, and if they choose no, they are directed to continue reading on page 18. On each of those pages, they have further choices and so on throughout the book. Some pages do not have any choices, and thus these are ending pages of that version of story. There may be many such ending pages in the book, some of which are good, and others which are not. So this is an interesting book, and it's more like some online tests that depending on different answers you give, your next question might be different. And now let's say you are the editor of one of these books, and you must examine two features of the Choose Your Own Adventure book. First, ensure that every page can be reached. Every page can be reached. Otherwise, there is no reason to pay to print a page which no one can ever read. Two, find the shortest path so that readers will know what the shortest amount of time they need to finish one version of the story. So we have two problems to solve. First, to check if every page is reachable, and the second one is to find the shortest path, which is the minimum number of pages you need to read to finish a story. Now let's see the input specification. The first line of the input contains n, the number of pages in the book. So this is the total number of pages for the book. Each of the next n lines contains an integer I, which is the number of different options from page I. So in the next n lines, each line is for a page, and the first number is how many options you have on this page to jump to other pages, and then follow all the pages you can jump to. And then if it's 0, if the first number on this line is 0, that means this is an ending page, and there will be at least one ending page in the book. There need to be at least one story in the book though. Note that you always begin the book on page 1, and these two are only for the marks for this problem. So here we are solving the problem, so we don't care about this much. And then the output. So the output will be two lines. The first line will contain y if all pages are reachable, and n otherwise. So it's either a y or n. The last line will contain a non-negative integer k, which is the shortest path a reader can take while reading the book. So the number on the second line is the minimum number of pages you need to read to finish a story. And now let's say the sample. Sample input 1, they have 3. This is the total number of pages, so we have 3 pages. And on the first page, we have 2 options to jump to page 2 or page 3. And then on page 2, there are no options, which means this is an ending page, and same for page 3. And in the output, we have a y, which means all the pages, page 1, page 2, page 3 are reachable. And then we have the second line as 2. So you need to read 2 pages to finish one story in this book. And then let's see sample input 2. Same thing, we have 3 pages. And on the first page, we can jump to page 2 or page 3. On page 2, this is an ending page. But on page 3, this is jumping back. So you have the option to jump back to page 1. So that could be a loop. And in the output, and the same thing, these 3 pages are all reachable. So there is a Y here. And to finish the shortest story, you need to read at least 2 pages. So 2 is here. And now we need to consider how to implement the book structure and how to check the 2 functions. So based on our understanding of the problem, we can use a tree for the book structure. I have an example here. So starting from page 1, you can jump to different pages. And for those leaf nodes in the tree, those are the ending pages. We have 5, 6, 3, 8, 9 here. And this page 7 is not connected to any node, so it's pretty standalone. So it's not reachable. You cannot reach page 7 from page 1. So with such a structure, we should find out page 3 and page 7. When we know page 7, we know that not all the pages are reachable, so we should give a n on the first line. If we don't have such nodes, then all the pages are reachable, and that's okay. We should give a y, and then we should find one node from the leaf nodes that is the shortest path to go from page 1 to this page. And we also have the situation that from a node, probably you're not always going downward, and you can jump back. And in our code, we should be able to handle this to avoid an infinite loop. And now we have this problem understood and analyzed. Now let's see how we solve the problem in code.